Previously at Thomas Machine and Foundry. Last time, we followed this casting through our cleanup department, where flash, gates, and risers were removed, surfaces were blended, and every detail was refined in preparation for machining. Now, that journey continues as the casting arrives at its next destination, the machine shop. After cleanup, every casting is placed into transfer totes and delivered directly to the machine shop, where they're staged and queued for production. Although the casting already resembles the finished product, there's still one critical step before it can become a precision component. Before machining begins, each casting is securely located into a dedicated fixture. This fixture positions the casting in exactly the same location every single time, ensuring every machine feature is held to the tight tolerances that our customers expect. One of the greatest advantages of casting is that it produces what's known as a near-net shaped part. Instead of starting with a solid block of aluminum and machining away most of the material, we cast the part with nearly all of its final geometry already in place. Additional machining stock is added only where precision surfaces will be required. This means that the machine only removes the material necessary to create the accurate mounting surfaces, precision bores, and threaded features. The result is less material waste, shorter machining times, lower tooling costs, and a more efficient manufacturing process. Our first operation uses a 3-inch face mill to machine the bottom of the casting. This creates a perfectly flat reference surface that establishes the foundation for every machining operation that follows. Next, a smaller face mill finishes the front mounting surface where the grinding plates will be installed. The same tool also machines the rear of the part and the top of the hopper, creating a smooth, flat opening that's easier to clean and provides the finished appearance customers expect. You may notice the machine automatically changing tools throughout the program. Every cutter has been selected for a specific operation. Some tools are designed to remove material quickly. Others are chosen for maximum rigidity, exceptional surface finish, or the tight tolerances required for precision features. Selecting the right tool for each operation is just as important as the machine itself. Together, the tooling, fixturing, and machining strategy determine the quality of the finished component. The next operation drills 4 mounting holes into the base of the casting. These holes allow the grade mill to be securely bolted down if the customer chooses to permanently mount it during use. Now we begin machining one of the most critical features of the entire part. This roughing bar removes the majority of the material, bringing each bearing bore close to its final dimension while maintaining rigidity and accuracy. As impressive as the cutting process is, the real efficiency comes from the machine itself. On a traditional machining center, the production happens one part at a time. An operator loads a casting, closes the door, starts the machine, and waits. When the machine is complete, the machine must stop so the finished part can be removed and the next one loaded. During that entire loading process, the spindle isn't making chips. But our horizontal machining center works differently. Instead of a single workstation, it has 2. While we're watching one casting be machined inside the enclosure, the other casting is being unloaded and the next one prepared on the opposite side of the machine. When both operations are complete, the pallet rotates 180 degrees and the finished part exits the machine. The next casting then moves into position, and the next machining cycle begins again almost immediately. Instead of waiting on the operator, the machine spends more time doing what it's designed to do, making parts. The finishing boring bars follow immediately behind. Unlike the previous roughing tools, these remove only a small amount of material, producing an extremely round, smooth, and precisely sized bore for the bearings. These bores are critical to ensuring the grade mill operates smoothly and efficiently for years to come. Next, a rigid spot drill accurately locates the threaded mounting holes. By creating a precise starting point, the drill that follows begins exactly where it's intended, helping maintain accurate hole locations. The drill then creates the correct hole size needed before threading. Although it appears simple, this step ensures that the tap has exactly the right amount of material to produce a strong, consistent thread. Now the machine cuts the internal threads. These threads will secure the grinding plates to the grain mill body, making both accuracy and thread quality essential. As machining nears completion, a chamfer tool breaks the sharp edges left by any previous operations. These small chamfers improve the assembly, remove sharp edges, and add the finishing touches in areas that would be difficult to reach by hand. The final machining operation permanently engraves identifying information directly into the bottom of the part. After a dozen tool changes and hundreds of precisely controlled machining movements, what began as a rough aluminum casting has now become a precision machine component. Every mounting surface, every precision bore, every threaded hole has been machined to its final dimensions. And this is the result. What began as molten aluminum poured into a sand mold has become a finished grain mill, ready for powder coating, assembly, and years of service. This is how it's made at Thomas Machine and Foundry.